Hello everyone, welcome to Epsilon Pro Academy. In today's lesson, our main focus is in the naming of organic compound, specifically from the functional group known as the alkane family. So we are going to look at how to name the alkane, the nomenclature of alkane. Let's consider the first example. In the nomenclature of an organic compound, the first thing we must determine is to find the parent hydrocarbon. What is parent hydrocarbon? Parent hydrocarbon is the longest continuous chain of carbon atom in the molecules present. So we are going to count the total number of carbon atom in a row. That is called the continuous chain. So we have 1, 2, 3, 4, 5, 6, 7. Now take note of this. 1 carbon is called butane, 2 is called ethane, 3 is propane, 4 is butane, 5 is pentane, 6 is hexane, 7 is heptane, 8 is octane, and 9 is nonene, whereas 10 is decane. So on the board we have 1, 2, 3, 4, 5, 6, 7. This is the simplest example. So the name of this compound, since the 7 carbon atom, it is called heptane. Let's consider the next example on the board. Now take note of this. When it comes to the nomenclature of an organic compound, the first thing we must determine is to find the longest carbon atom present in the molecules, or in other words, to find the parent hydrocarbon. Again, take note of this. After counting the longest carbon atom present in the molecules on the board, if there is any carbon atom that is not part of the longest chain counted, such carbon atom is called a substituent. Okay, on the board, let's check. 1, 2, 3, 4, 5. They are in a row. 1, 2, 3, 4, 5, 6. We have gotten 5. We have also gotten 6. Let's count from here. 1, 2, 3, 4. We have also gotten 4. 1, 2, 3, 4, 5, 6. So the longest carbon chain on the board is 6. And 6 is known as hexane. The parent chain, parent hydrocarbon, equal to 6. Now we are going to count this in such a way that the substituent has a lower numbering. We are going to count this in such a way that the substituent has a lower numbering. Okay, counting from here, we have 1, 2, 3, 4, 5, 6. This is the parent chain, and there is a carbon atom which is not part of the parent chain. Such carbon atom is called a substituent. So this carbon atom is substituent. Numbering from here, we have the substituent on the 4th carbon atom. That is 4th carbon atom, and it is called 4. Since it is 1 carbon atom that is a substituent, when it is 1, it is called methane. So 4 methane. When counting from the right hand side over to the left hand side, let's see what it will be. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So counting from here, the substituent is attached to the 3rd carbon atom. The substituent is attaching to the 3rd carbon atom. So we are going to have 3 methyl. Now, in this naming of organic compound, our aim is to ensure that the substituent has a lower number. a lower number. So between 4-methyl and 3-methyl, the lowest is 3-methyl. We are going to accept 3-methyl and cancel the 4-methyl. So the name of the compound becomes 3-methyl. Since the parent hydrocarbon is 6 and 6 represents hexane, it becomes 3-methylhexane. In the nomenclature of an organic compound, we use hyphen to separate the number from the word. Take note of this. Hyphen is used to separate the number from the word. And the name of this compound on the board is 3-methylhexane. Let's look at the next example on the board. The first thing we must determine is to find the longest carbon atom present in the molecule on the board. And every other carbon that is not part of this longest chain is called a substituent. Okay, starting from here, we have 1, 2, 3, 4, 5, 6. The parent chain or parent hydrocarbon is 6, which is hexane. And we have a substituent over here. And the next question is this going to be numbered from here down to this side or from here down to this position? Let's test. Starting from here, we have 1, 2, 3, 4, 5, and 6. So the substituent is attached to the 4th carbon atom. In the 4th carbon atom, we are having 1 C, which represents methane. So we have 4-methyl hexane. The name of the compound becomes 4-methyl hexane. Then counting from here down to this side, we are going to have 1, 2, 3, 4, 5, and 6. At this point, the substituent is attached to the 3rd carbon atom, which is methyl. So we are having 3-methyl hexane attached the parent chain to it, hexane. In the organic chemistry or in the nomenclature of an organic compound, our aim is to ensure that the substituent has lower number. So we are going to pick this over this. The reason is because the substituent, which is methyl, has a lower number of counting on the board. So the correct name of this compound is 3-methylhexane. If you can actually solve this, pause the video at this point and attempt it. Okay, let's solve this. The first thing you must determine when it comes to the nomenclature of an organic compound is to determine the longest carbon chain or the parent chain. So the parent chain is equal to, counting from here, we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So the longest chain on the board is 7 carbon atom, and it is called the heptane. Next is numbering. Should we number from this part down to this part or from this part down to this part? Alright, we are going to take both options. Let's examine both options. Counting from this part, we have 1, 2, 3, 4, 5, 6, and 7. Now take note of this. The longest continuous chain is just this alone. This is the longest continuous chain on the board. If there is any other carbon atom which is not part of the longest chain, such carbon atom is called a substituent. So we have this as a substituent. There is a carbon atom which is not part of this line, and we also have this as a substituent. Take note of this concept. There are two substituents on the board. Now from here we have a substituent on the fourth carbon atom on the board, a substituent on the fourth carbon atom, and the substituent is called methane. The reason is because it is just one C. So we have 4-methyl. Again, we have another substituent which is attached to the fifth carbon atom, and the substituent is called methyl because it is just one C, one carbon. So we have 5-methyl. We use hyphen to separate the number from the letter. Take note of this. Hyphen is used to distinguish between the number and the letter on the board. Okay, so we have 4-methyl and 5-methyl, which is the total of 4 plus 5 gives 9 substituents. We have 9 substituents counting from the right to the left hand side. Now let us take the same option from the left hand side to the right hand side. Moving from here, we have a substituent. The first substituent is attached to the carbon 3, to the third carbon atom on the board. The first substituent, which is methyl, is attached to the third carbon atom on the board. And we have 3-methyl. Again, we have another substituent which is attached to the fourth carbon atom on the board, 4-methyl, which gives 3 plus 4 equal to 7. So we are going to compare this with this. Now take note of this. So one of the concepts or one of the rules in nomenclature of an organic compound is that when naming an organic compound, we ensure that the number of substituents are lower. Okay, between 7 and 9, we are going to pick the lowest number of substituents or the total number of substituents present. And 7 is the lowest. Between 7 and 9, we have 7 as the lowest. Therefore, the correct naming is going to be this. So we have on the board 3-methyl, 3, 4-dimethyl, and the parent chain is heptane. We use comma to separate a number if 2 or more the same substituents are present. Again, if 2 or more identical substituents are also present, we use a multiplier prefix. The multiplier prefix, they are di, tri. 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. And the correct naming of this compound is 3,4-dimethyl heptane. In this compound board, we are still working with our basic rules. So the first thing is to determine the longest continuous carbon chain present in these molecules. And the longest chain, counting from here, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So the longest continuous chain is 6. Longest chain is 6. 1, 2, 3, 4, 5, 6, which is hexane. Now the next is the correct numbering. Counting from here, we obtain 6. 1, 2, 3, 4, 5, 6. Counting from here, we also obtain 6. 1, 2, 3, 4, 5, 6. We are going to take one direction. Taking this direction, moving in this direction, okay, this is the longest continuous chain on the board. Now, in this longest continuous chain, if there is any carbon atom which is not part of the longest chain, such carbon atom is tagged as a substituent. Numbering from here, we have 1, 2, 3, 4, 5, and 6. We have the first substituent, which is methyl, attached to the second carbon atom. So we have 2 methyl. Moving down to this place, we have another substituent attached to the third carbon atom. And the substituent is called ethyl because it is made up of 2 carbons. So this is ethyl attached to the third carbon atom, and we have 3 ethyl. Okay, so the total number of all the substituents present in this compound, naming from this part down to this portion, is 2 plus 3, 5. Let's count from here down to this part. So if you are counting from here down to this part, it is going to be 5 and 6. So the substituent is attached to the 5th carbon atom, and the 5th carbon atom is holding a methyl. 5 methyl, and the next substituent is attached to the 4th carbon atom. The 4th carbon atom is holding ethyl. So the sum or the total number of all the substituents present when counting from this portion down to that portion is 5 plus 4, which is equal to 9. So between the 5 and the 4, we are going to pick the lowest number of substituents present. And the lowest number of substituents is 5. The lowest number of substituents is 5. And the compound is 3 ethyl, 2 methyl, hexane. The parent chain, hexane. So we have 3 ethyl, 2 methyl, hexane. If we have 2 or more different substituents present with different prefix, it is arranged in alphabetical order. So between methyl and ethyl, we have E before N. So that is the reason for this arrangement. 3 ethyl before 2 methyl hexane. And the correct answer is 3 ethyl, 2 methyl hexane. Let's check another example. Before attempting this example on the board, take note of this concept. If 2 or more different chains of equal lengths are present, pick the one that has the highest branches, the one with the most branches. Okay, on the board we have, counting from here, according to the rules, the longest carbon chain present in the molecule. So we count from here, 1, 2, 3, 4, 5, 6, 7. Again, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The longest carbon chain on the board is 7. The longest or the parent chain, parent hydrocarbon is 7, which is called the heptane. Heptane. Counting from here, we obtain 7. Counting from here, obtain 7. And counting from here, down to this portion, we also obtain 7. So now we are picking the one with the highest number of branches. So if I'm counting from here, this person become a branch. Still, I'm not going to this direction. That is, we have 1 branch, 2 branch, and 3, 4 branches. Again, counting from here, we obtain, this is a branch 1, this is another branch 2, branch 3, this is a branch 4, this is another branch 5. So we have 5 branches. Again, counting from here down to that portion, we have, this is a branch, since you are going to this direction. This is a branch, since you are going to this direction. This is a branch, since you are going to this direction. This 2 is also a branch. So we have 2 of 1, 2, 3, 4, and 5 branches. So let us go with the straight chain molecules. We are going with this. Okay, this is the parent chain on the board. Now the second thing you must obtain is the numbering. Numbering from this part, 1, 2, 3, 4, 5, 6, and 7. Now we have the substituent. Take note, this is substituent, 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 and substituent. Any carbon atom that is not part of the branch is called a substituent. Okay, so counting from here, we have the first substituent, this and this. So on the second carbon atom, we have 2 substituents attached to it. The first substituent is methyl, and another substituent is also methyl. We are having 2 methyl from the upper branch, and again 2 methyl from the lower branch. If 2 or more substituents are attached to the same carbon atom, assign the same number to it. That is the basic rule. Moving over to this side, we have another substituent attached to the third carbon atom. So we have 3 methyl, 3 methyl. The reason this is called methyl is because it has 1 carbon as a substituent. 3 methyl, 3 methyl. Moving over to this side, we have another substituent. And this substituent is called 1, 2, 3. Propane. And it is attached to the 4th carbon atom. So we have 4 propane. Again, moving over to this portion, we have another substituent, and it is attached to the 5th carbon atom. Since there are 2 carbons as a substituent, the name is ethane. So we have 5 ethane. So let us add up. Summation, 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 4 is 11. And 11 plus 5 is 16. We have the total of 16 substituents present when counting from the left hand side to the right hand side. Let us also count from the right hand side down to the left hand side. The first substituent is on the 3rd carbon atom. on the third carbon atom, and it is ethyl. So we have 3 ethyl, 3 ethyl. Next carbon atom is attached to the fourth carbon atom. Next substituent rather is attached to the fourth carbon atom, and it is 1, 2, 3 propane. So 4 propane, 4 propene, propene, and ethyl. Okay. Again, moving over to this side, we have another substituent which is methyl attached to the fifth carbon atom. 5 methyl. Moving over to this side, we have another substituent, 2 substituents attaching to the sixth carbon atom. The upper substituent and the lower substituent, they are both methyl and methyl. So we have 6 methyl and 6 methyl. 6 methyl and 6 methyl. Okay, that's the last. So let us add up. 3 plus 4 is 7. 7 plus 5 is 12. 12 plus 6 is 18. And 18 plus 6 is 24. So moving from the right hand side over to the left hand side, we have the total substituents of 24. But moving from the left hand side to the right hand side, we are obtaining 16 substituents. So we are going with the one with the lowest number of substituents present. So we are going to name this using alphabetical order. So using alphabetical order, E comes before M and M comes before P. So it's going to be 5 methyl, 5 methyl, 5 ethyl rather, 5 ethyl. There are 3 methyl as a substituent on the board. 2 methyl, 2 methyl, and 3 methyl. We are going to use multiplier prefix: tri, tetra, penta, hexa, and so on. So when we have 3, it is called tri. So we have 2, 2, 3, 2, 2, 3, tri methyl. Then the next substituent is propene, 4 propene, 4 propene. Attach the name of the longest chain to it, which is heptane. Heptane. So the name of the compound or the name of this structure is called 5-ethyl 2,2,3 trimethyl 4 propene heptane. Very simple.